The nerve impulse. What is resting potential? How is resting potential created in a neuron? And what is an action potential? So the resting potential of most mammalian cells, or neurons, is minus 70 millivolts. So in a neuron's resting state, the outside of the membrane is positively charged compared to the inside, because there are more positive ions outside than inside, so the membrane is polarized. And there's a difference in charge or voltage, and the resting potential is about minus 70 millivolts. So now we'll look at the movement of sodium and potassium. So the resting potential is maintained by the sodium-potassium pump and potassium ion channels. So the sodium-potassium pump uses active transport to move 3 sodium ions out of the cell for every 2 potassium ions it moves in. And ATP is needed to do this. So potassium ion channels then allow facilitated diffusion of potassium ions out of the neuron once it's just been pumped in, down their concentration gradient, and that leads to a build-up of positive ions on the outside of the axon, so leaving the inside relatively negative. So the movement of ions, the sodium and potassium ions, across the axon membrane is controlled by phospholipid bilayer, which prevents sodium and potassium ions diffusing across it, intrinsic proteins which span the bilayer, which contain ion channels, and some channels have gates which can be opened or closed, and there are different gated channels for sodium and potassium, and some channels are open all the time. Some intrinsic proteins actively transport potassium ions into the axon and sodium ions out of the axon, which is called the sodium-potassium pump. So therefore, the inside of the axon is negatively charged relative to the outside. So the resting potential inside the axon is approximately minus 70 millivolts. And the axon is said to be polarized. And the establishment of this potential difference between the inside and the outside is due to a few things. So the fact that 3 sodium ions are actively transported out. So you can see here, this is the outside, this is the inside. So 3 sodium are pumped out for every 2 potassium that are pumped in. So active transport of sodium ions is greater than the active transport of the number of potassium ions, because 3 sodium move out for every 2 potassium that move in. And although they're both positively charged, the outward movement of sodium ions is greater than the inward movement of potassium ions. So there's more sodium ions in the tissue fluid surrounding the axon than in the cytoplasm. And there's more K+ ions in the cytoplasm than the tissue fluid, which creates a chemical gradient. And at rest, the potassium ions channels are actually open. So that means that potassium just diffuses straight back out again after it's been pumped in naturally because of its diffusion gradient. So then you just get a massive build-up of positive ions on the outside and hardly any positives on the inside. But most of the sodium ion channels are closed, so they can't actually get back in. So you just end up with lots of positives on the outside and very few on the inside, which creates a potential difference. And it makes the inside of the axon negative relative to the outside. So you can see here, 3 sodiums are pumped out of the axon for every 2 potassiums are pumped in. But at rest, the potassium channels are open, so once the potassium's been pumped in, it just diffuses back out down its electrochemical gradient, and therefore you end up with lots of positives on the outside and hardly any on the inside. So the axon membrane is about 100 times more permeable to potassium, which therefore diffuse back out of the axon faster than sodium ions can diffuse back in, increasing the potential difference between the negative inside and the positive outside the axon. Apart from the chemical gradient that causes movement of potassium and sodium ions, there's also an electrochemical gradient or electrical gradient. So as more potassium ions diffuse out of the axon, the outside becomes more positive and there's more outward movement of the potassium, but it then becomes difficult because as there's more and more positive, they get repelled. So eventually an equilibrium will be reached, which is about minus 70 millivolts inside the axon. So that is how the resting potential is maintained.